To demonstrate this experiment, we need two ICs. So one is 74151 IC. In this IC, there are 16 pins. So there are 16 pins in this IC. For each side, there will be 8 pins. Okay. So in this IC, each side there will be 8 pins, and there is a notch at the top. Okay, so this is 74151 IC, which is nothing but a multiplexer IC. Multiplexer IC means there will be n number of inputs and only one output. So by using control pins, we usually give the inputs through or via the switches. So here there are 4 inputs we are using. So the complete explanation that will be given in the previous video. Now I will show you the demonstration. Okay, so this is the 74151 IC, and another IC we need is 7404. So to take the complement of a value, we need NOT gate. NOT gate IC is a 7404. So obviously you have obviously we know that this IC has 14 pins in total. So there are 7 pins on each side. We have used this IC in the previous experiment. You know this, I think. Okay, so there are 6 gates, 6 NOT gates in this. So there will be only one input and one output. And 14th pin will be connected to VCC, and the 7th pin will be connected to ground in NOT gate. But whereas in 74151, that is multiplexer IC, here 16th pin will be connected to VCC, 8th pin will be connected to ground. Okay, so this is the trainer kit which we are using in our lab. So by using this trainer kit, I will show you the demonstration. Okay, so I will take up the first IC, that is 74151. So here we can see there is a notch or there is a mark at the top. I will fix this onto the first IC base. Okay, so as I said, this IC has 16 pins, 8 pins on each side. So here here to fix the patch cords we have 10 pins. Okay, so as we have only 8 pins on each side in an IC, we will be using only 8 pins on each side to fix a patch cord. To fix a patch cord, we use only 8 pins on each side. So this is pin number 1, this is 2, 3, 4, 5, 6, 7, 8. And from the bottom right corner, this is 9th pin, 10th, 11th, 12th, 13th, 14th, 15th, and this is 16th. Okay, so I will fix this 74151 IC on the first IC base, and I will take up this 7404. So if we have any, if you want to take any complement of a value, then we will be using 7404, that is NOT gate. So this IC has only 14 pins, 7 pins on each side. I will be fixing this IC onto the second IC base. Okay, so here we usually consider only 7 pins on each side to fix the patch cords, because IC has only 7 pins on each side. Now coming to the circuit diagram. So this is the circuit diagram we have for 18:1 multiplexer. So here you can see there are 3 control pins. So these 3 control pins are nothing but the input pins, and we have another input, that is D. So totally we have 4 inputs, A, B, C and D. Here A, B, C are also called as the control pin. Okay, so here you can see these are the pin numbers for ABC, where the pin number for A is 9th pin. So here in the trainer kit, so this is the first pin, second, third, fourth, fifth, sixth, seventh and 8th from the bottom right corner. So the pin numbers usually starts from 9, 10, 11, 12 like this. So this is the 9th pin. So I will connect this 9th pin to the first input, that is A. Next one is B. For B, the pin number is 10. So this is the 10th pin in 74151 IC. So I will connect this 10th pin to the second input, that is B. And the third input C is, the pin number for that C is 11. So coming to the trainer kit, this is the 11th pin. So this pin, this patch cord will be connected to the third input, that is C. Now we have connected 3 inputs, but we have left out another input, that is D. We will connect that later. Okay. Now you can see to give a power supply to the IC, so the 16th pin is connected to VCC. So coming to the IC base, the first IC base, so this is the 16th pin that is connected to the plus VCC, plus 5 volts. Next, So here in the circuit diagram, 8th pin is connected to ground. So now I will connect this 8 pin. So this is pin number 1, 2, 3, 4, 5, 6, 7 and 8. So this is the 8th pin. So this patch cord I will connect that to the ground. Okay. Next we have 7th pin. 7th pin is low. Low means we need to connect the patch cord from 7th pin to the ground. Low means ground. So again we need to connect this 7th pin to the ground. So this is 1, 2, 3, 4, 5, 6, 7. 7th pin, again I will connect that to the ground. Next you can see here the 5th pin is output from the 8:1 multiplexer. So 8:1 multiplexer contains 8 inputs and only 1 output. So here the output is from the 5th pin. So coming to the IC base, so this is the 5th pin. I will connect this to the logic output. So I will connect this to the logic output, that is output 1. So there will be only one output in this circuit. Now we are done with input and output we are done with control pin connections and output pin connection. Next, coming to the 8 pins, what we have here, that is the pin number starts from pin usually starts from D0 to D7. So I'm giving the demonstration for this given expression. So the solving of this expression has been explained in the previous video. Now to demonstrate, I will take up this table. Okay, so here you can see here. So for D0, that is the first input, the value which we have got is 1. 1 means we need to connect that to VCC. Suppose if we get 0, then what we need to do is we need to connect that to the ground. Suppose if we get D, then we will connect that to the 4th input, that is D. Suppose if we get D bar, what we need to do is we need to take a complement of D. So to take a complement of D, that's why we are using the NOT gate 7404. Now coming to the first input, that is D0, the value of D0 is equal to 1, and in the circuit diagram you can see D0 is connected to 4th pin. Okay, now I will take a patch cord. So I will connect one end of the patch cord to the 4th pin, and the value of D0 is equal to 1. So that what I will do is from the 4th pin I will connect the another end of the patch cord to the plus VCC. Okay, so if you get 1, we need to connect a plus VCC. If we get 0, then we need to connect that to ground. If we get D, then we need to connect that to the 4th input. If we get D bar, then we need to consider the NOT gate. Okay, now we are done with the first input connection D0. Next, coming to the second input, that is D1. So the value of D1 is equal to D bar. Okay, so here EVM variable which I have taken to realize this is D. So here for D1 we got D bar. From this circuit diagram we come to know that D1 belongs to 3rd pin. So what I will do is I will take a patch cord. I will connect one end of the patch cord to the 3rd pin, and another end what I will do is I will connect that to the D. D means nothing but the 4th logic input. D is the 4th logic input, but we need D bar, right? So we cannot connect this to D. So I will connect one patch cord, I will take another patch cord, I will connect that one end of that patch cord to D, and another end what I will do is I will connect this to the first pin of 7404. First pin of 7404 is nothing but the NOT gate. In NOT gate, the first pin is an input pin. So what I am doing is I am connecting one end of the patch cord to the input D, and another end I am connecting that to the first pin. And what's the output of the NOT gate? Obviously we get D bar. That output I am connecting that to the 3rd pin, because from the circuit diagram we come to know that D1 belongs to 3rd pin and D1 value is D bar. So what we have done is I have taken the 4th input, I have connected one end of the patch cord to D, that is 4th input, and another end of the patch cord I have connected to the first pin of 7404, which means that for the first NOT gate the input is D. If I send an input D to the NOT gate, then what will be the output? Output is D bar. So that output I am connecting that to the 3rd pin, because 3rd pin belongs to D1, where the value of D1 is equal to D bar. Now we have done with the D0 and D1. Next coming to D2. D2 has a value 1, which means that 1 means I need to connect D2 to plus VCC. From this circuit we come to know that the D2 pin belongs to D2 input belongs to second pin. Okay, so from the second pin I will connect the one end of the patch cord to the second pin, another end I will connect to plus VCC, which means because we got D2 is equal to 1. Next we have D3, where D3 value is equal to D bar. So you can see here D3, the D3 input belongs to pin number 1. So what I will do is I will take one patch cord and one end of the patch cord will be connected to the first pin, another end of the patch cord will be connected to D bar. D bar means output of the NOT gate, where I am connecting that to the second pin of 7404, because 7404 second pin is nothing but the output. For that input is D, and obviously if we give D as an input, the output is D bar. The output is from the second pin, so that's why I have connected the other end of the patch cord to the D bar, that is second pin of 7404, and the other end, the first end is connected to the first pin of 74151 IC. Now we are done with D3, the fourth input. Next, moving on to the next input, that is D4. For D4 the value is 1, which means that I need to connect this input to the plus VCC. From this circuit diagram we come to know that the input D4 belongs to 15th pin. So coming to here, trainer kit. So this is 8th pin as we know. This is 9th, 10th, 11th, 12th, 13th, 14th, and this is 15th. What I need to do is I will need to connect this 15th pin to the plus VCC, because we get D4 is equal to 1 and D4 belongs to 15th pin. So from 15th pin what I have done is I have connected one end of the patch cord to the 15th pin, another end what I am doing is I am connected that to the plus VCC. We are done with input D5. Next moving on to D4. Next moving on to D5. The value D5 is nothing but the 6th input pin. For 6th input the D5 value is equal to 0. So from this circuit diagram we come to know that D5 belongs to 14th pin. That one end of the patch cord will be connected to the 14th pin of 74151. Another end is connected to ground, because the value of D5 is equal to 0, which means that I will take a patch cord, I will connect one end of the patch cord to the 14th pin, another end of the patch cord I will be connecting that to the ground. Okay, now we are done with the D5 input connection. Next D6, the value of the 7th input is 1. So coming to the circuit diagram, the 7th input D6 belongs to 13th pin. So coming to 74151 IC, this is 9th pin, this is 8th pin actually. This from the bottom right corner, this is 9th, 10th, 11th, 12th and 13th. What I need to do is I need to connect this to the plus VCC, because we have a D6 value is equal to 1 and D6 belongs to 13th pin. One end of the patch cord is connected to 13th pin, another end is connected to plus VCC, because we got 1. Coming to the last output, that is a D7. So what I need to do in D7 is the value which we have got, the last 8th input value is a D bar. So coming to the circuit diagram, D7 belongs to 12th pin, which means that I need to take a patch cord, one end will be connected to the 12th pin and another end is connected to D bar. So D bar means the second pin of 7404 IC. So now we are done with all the input, output and control pin combination. The connection, and we have not given the power supply to the 7404 IC. That 7404 IC I have connected to the second IC base. So here, as I discussed earlier, 7404 has only 14 pins, 7 pins on each side, and this 14th pin is connected to plus VCC. And the 7th pin is connected to ground. We are done with the connection. Now we need to verify this circuit by using the truth table. Now I will switch on the trainer kit. So this is the truth table what we have. So this truth table contains A, B, C, D, the 4 inputs and 1 output in the input combination. So here we have 4 input. This is A, this is B. So the first one is A, second one is B, third one is C, and the fourth one is D. I need to give inputs through these input switches and I will get the output. So if I get output is equal to 1, then LED will get emitted from the first output pin. If I get output is equal to 0, then no LED, so no light will be emitted from the LED. Now coming to the first input combination, where A is equal to 0, B is equal to 0, C is equal to 0 and D is equal to 0, the output what we should get is 1. So here coming to the input combination, all these A, B, C, D are in low state, which means that A is equal to 0, B is equal to 0, C is equal to 0 and D is equal to 0. The output what we have got is 1. For that's the reason LED is emitting, the light is emitting on the LED. So this is how we need to verify the truth table. Another combination I will take, another input combination I will take, that is the second input combination. So 0001, which means that A is equal to 0, B is equal to 0, C is equal to 0 and D is equal to 1. For that what we should get is output 1. So here A is equal to 0, which is in low state, B is equal to 0, which is in low state, C is equal to 0, which is in low state, D is equal to 1. I will turn this switch to the upwards. Now we can see here the light will get emits from the D because D value is equal to 1 and the output what we have got is 1 because the output LED, the light is emitting from the output LED. Now I will take another input combination. So here I will take this 0111, which means that A is equal to 0, B is equal to 1, C is equal to 1 and D is equal to 1. For this what I have got is the output should be 0. Now coming to the input switches. So here A is equal to 0, B is equal to 1, C is equal to 1 and D is equal to 1. So I have, so you can see here 3 lights gets emitted from the LED, that belongs to the input B, C, D, where the value of B, C, D are equal to 1, and for this input combination, that is 0111, what's the output we should get? We should get 0. So we have got the correct output. So which means that if we get 0 as the output, no light will be emitted from the output LED. So another input combination I will take. So this is the last input combination I will take, that is all ones. When A is equal to 1, B is equal to 1, C is equal to 1, D is equal to 1. What's the output we should get? We should get 0. So coming to here, see here, this is A is equal to 1, which is nothing but A is in high state, B is equal to 1, B is also in high state, C is equal to 1, C is also in high state, D is equal to 1, D is also in high state, and the output which we are getting is 0 because no light is emitted from the output pin. So if we don't have any light which emits from the output pin, then the output is 0. So this is how we need to verify the circuit.
The desktop, we have one application called Xilinx IC 8.1. Double click on that application. Wait for some time and you will get a tip of the day. Close that. So here you can see there are some projects that has already been opened. We need to close this first. Okay, go to file and select close project. We need to open a new project. Whenever we want to execute the program, first we need to create a project. After creating a project, then we need to create a file. In that file, we need to type the program. Now I will create the project. So go to file, select new project. So here we need to give the project name. So let it be your USN name. I will give project name as a 4VM19IS. So you can give anything. So let it be your USN name. Okay. Then project location. So let it be as it is. Then top level source type. Let it be HDL. Click on next. Then again click on next. No need to worry about all these settings. Click on next. Again click on next. Click on next. After that, click on finish. Now you can see in the source window, we have created the project. Okay, so after creating the project, now we need to create a file to type the program. We need to create a file. So select this project, which is on the source window. Select this, then right click on new source. So we are creating a file here. So select VHDL module, that is a very log high definition language module. You need to select this source type, enter the file name. So here I will enter the file name as MUX because I am writing the program for 8:1 multiplexer. MUX stands for multiplexer. Let it be MUX. You can give any file name, okay, but both file name as well as the project name should not be the same. So let it be unique. Okay, I will enter MUX. You can give anything. Click on next. Here we need to give the port names, whether it is input or whether it is output. We need to give the port names. In 8:1 multiplexer, you can see here. So in 8:1 multiplexer, we have 8 inputs on the circuit. So see here, we have 8 inputs that ranges from D0 to D7, and we have only one output, that is Z out, and we have 3 control pins, that is ABC. So here the control pins are input pins, Z out is output pin, and this D0 to D7, let it be input pins. So this should be input pin actually. Okay, now I will select these as the port names here. Okay, first I will select D. D is an input pin. I will enter D. Next, I will select port names for I will select the input controls or select lines, that is ABC. I will just type select, but in that select there are 3 pins ABC. In D we have 8 pins, 8 because we have 8 inputs, that is to D7, and we have one output, that is Z out. Okay, so Z out should be output. D and select. So this should be the direction of this port should be input, and Z out should be output. So after selecting the port names as input and output, then click on next. So click on finish. Now we need to type the program here. So here we have a MUX file. Click on this MUX file. So here below you have one MUX file. So select that MUX file. Come here. So between a begin and behavioral, I will paste the program. So for the time being, I'm just copying the program. You need to type it while executing. Okay, so here within begin and end behavioral, just I'm typing the program without comments. Okay, then in the program, so I have explained this program in the other video. So in that video, what I have explained is, yep. So here we have D. So that is in standard logic vector. It should be vector because it ranges from 7 to 0, 7 down to 0. 7 down to 0 means there are 8 inputs, that is D7, D6, D5, D4, D3, D2, D1 and D0. So D input ranges from D7 to D0. D7 to D0. Likewise, coming to the select inputs, we have ABC, A, B, C, that is nothing but 3 select lines A, B, and C. So that is 2 belongs to A, 1 belongs to B, and 0 belongs to C. Okay, and Z is output standard logic. So we need to type this here. So we need to type this D in standard logic vector. It is a vector because it consists of 8 different inputs, 7 down to 0. I will type this here. So D in standard logic underscore vector open bracket 7 down to 0, because 7 down to 0, as we have 8 inputs from D7 to D0. So that's why I am representing this as vector that ranges from D7 to D0, and we have 8 inputs. Coming to the select, we have again that should be vector because there are 3 inputs A, B, and C. It should be standard logic vector. So underscore vector. We have 3 select lines. So I'm typing 3 down to 0. 3 down to 0. I will close the bracket. So here down to spelling is wrong. Okay. So this is what we need to do here. Okay. For D, it should be standard logic vector 7 down to 0. For select pins, it should be 3 down to 0. And for Z out, let it be standard logic. So I think we have done with the program. So we don't have any other things. Okay. Yeah. So we are done with this program. Next thing is we need to save this program and we need to check the syntax. Okay. After click on the save button. After that, select that file, select that MUX file. We need to check the syntax of this file, whether do we have any errors or not. So select this file, come to process window. We have one option called synthesis XST. Click on this plus, double click on this check syntax. Now you can see here we have a green tick mark, which means that the program has been successfully compiled without errors. Now what I should do is I need to set the waveform for this program. Now I need to set the waveform for this program. To set the waveform, select that MUX. That is nothing but where we have written the program. So first, before setting the waveform, we need to compile that. So after compiling, we got a zero, or we got a successful compilation that we don't have any errors in this. Then click on this MUX file, right click, new source. For this file, what I am doing is I am setting the waveform. So here in the select source type, you need to select test bench waveform, and create one file name. So give one file name. So here let it be MUXB. So the file name where I have written the program name, that file is MUX. Here in MUXB, I am setting the waveform. So I will click on this next button. So here MUX should be selected because MUX file is where I have written the program. Okay, this should be selected. So it is pre-selected actually. So no need to worry about that. Click on next button. Then click on finish. So after click on that finish button. So here, so we don't have any clock signals. So that's why you cannot select any combinational or single clock or multiple clock. You need to select this GSR FPGA. Click on finish. That's it. Okay, so this is the waveform screen where we need to set the waveform. So here for D7 is to 0, which means that D7 to D0. So there is one plus. Click on this plus sign. And also there are select pins. So click on this select. Click on this plus symbol. Okay. Now have a look on the truth table. So here you can see we have a truth table for where we need to use this truth table to verify the multiplexer program. Here select 2, select 1 and select 0. Select 2 is A, select 1 is B, select 0 can be C. Okay, for these 3 inputs, so how many input combinations are there? 8 input combinations are there. For A, that is a select of 2, we have 4 zeros and 4 ones. I will set this on the waveform. I will set A to 4 zeros and 4 ones. So this is 1 0. So a single waveform should contain both white color as well as a blue color. Blue color means the waveform is in high state. White color means the waveform is in low state. So both blue and white color forms one waveform. So 1 0, 2 0, here 3 0, here 4 0, next 4 ones. 1 1, 2 1, 3 1, and 4 1 after 0. Next, for select 2 here. For select 2, that is B input, we have 2 zeros, 2 ones. Again, we have 2 zeros, 2 ones. Now we will set this on the waveform. So coming to the waveform here, so I will select 2. So this is 1 0, this is 2 zeros, then 2 ones, 2 zeros again, 2 ones again. Next, for select 1, we have 0 1, again 0 1, again 0 1, again 0 1. That is for C input. Okay, so I will set the waveform. So this is 0, then 1 0 1 0 1 0 1 0. Okay. Now what we have done is we have selected the input waveform for A, B, C, where A is select for A, B, C. Wait a minute. So we have done one mistake here. This should be 2 down to 0. That is a select pin. For select pin in standard logic vector, it should be 2 down to 0. As we have only ABC, 3 inputs, 3 select inputs, so it should be 2 down to 0. Select of 2 will be A, select of 1 will be B, select of 0 will be Z. So we have done one mistake here. Instead of 3, we should have written 2 here. Okay, now I have done some changes on this program. I will click on the save button. After click on the save button, I need to verify whether it contains any errors. So I will go to this process window where we have a synthesis XST. In that, I will double click on this check syntax. After that, I will select the file where we have written the program. Then I will click on this new file. Then here I need to select test bench waveform. Then I need to select the file name where we are creating the input waveform. So here I will give a file name as MUX77. We can give anything. So just click on next, click on next, click on finish. Then here what we need to do is we need to select GSR FPGA. So select this GSR FPGA, click on finish. Okay, next we will set the waveform for select of 2. So 4 zeros, 4 ones, right? For A, 4 0 4 ones. So here we have 1 0, 2 0, 3 0, and here we have 4 0, then 4 ones. 1 1, 2 1, 3 1, and 4 1. Next for B, that is a select of 1. There are 2 zeros, 2 ones. So here 1 0, 2 0, then 2 ones. Then again 2 zeros, 2 ones. After that 0 1 0 1 0 1 0 1 0. Yeah, now we are done with setting the waveform for select pins. Next, we need to set the waveform for 8 inputs, that is D0 to D7. So either you can set it to low state or you can set it to high state. For D7, what I will do is let it be in low state. For D7, for D1, I will set it to high state. For D2, let it be 0. For D3, I will set the waveform to high state. For D4, let it be 0. That is in the low state. For D5, let it be in high state. For D6, let it be 0. So which means that the waveform is in low state. For D7, let it be in, the waveform will be in high state. You can see here for D of 0, I have set the waveform for 0. For D of 1, let it be 1. For D of 2, 0. For D of 3, let it be 1. For D of 4, let it be 0. For D of 5, let it be 1. D of 6, be 0, then D of 1, D of 7, let it be 1. So in 8:1 multiplexer, as we have 8 inputs and 3 control inputs, that is select inputs A, B, C. Here from the truth table, what we have studied is when we select 0, 0, 0, Z out, D naught will be selected. So we will verify this whether we will get the correct output or not. So I will save this waveform. So after this, click on, I will save this waveform. Waveform has been saved. Now we need to check the behavior of this waveform. So to check the behavior, go to source window. Here on the drop down menu, select a behavioral simulation. Select the file MUX77. Here in this, we have set the waveform. Select that file. So coming to the project process window. So here we have one process window. Here you can see we have a process window. So under that process window, we have an option called the Xilinx IC simulator. Click on that plus symbol. So when you click on that plus symbol, you will get a two option. In that, double click on this simulate behavioral model. Just double click on this simulate behavioral model. So coming to the waveform window, here we have a D of 7:0, which means that there are 8 inputs, D naught to D7. And SEL, that is the select input 2:0, which means that A, B, C. Click on this plus symbol. Okay, now we will verify this. So I will take up the marker. So go to simulation, select marker and single marker. See here, I have set the marker where the value of SEL2 of SEL2 is equal to 0 here, SEL1 is equal to 0 here, SEL0 is equal to 0 here. In that, coming to the truth table, what we have here. So here, when SEL2 is equal to 0, SEL1 is equal to 0, SEL of 0 is equal to 0. In the Z naught, D naught should be selected. D naught will be the output, which means that in multiplexer, whatever the value we give for the input, that will be the output. Okay, output in the multiplexer, the output depends on the input. So here we have set D naught is equal to 0. You can see here in the waveform, we have set D naught is equal to 0. That's why you can see a Z out. This Z out is equal to 0. Next, we will look for another input combination, that is yeah, so this is another input combination where SEL of 2 is equal to 0, SEL of 1 is equal to 0, and SEL of 0 is equal to 1, which means that 001. So on the truth table, you can see for 001, the output is D1. Output is D1, and coming to here, you can see D1, the value of D1 is equal to 1. Okay, as we have a D1 is equal to 1, then output Z out is also equal to 1, which means that in multiplexer, whatever the value we give as an input, that will be the output. So for 001, SEL2, when SEL of 2 is equal to 0, SEL of 1 is equal to 0, SEL of 0 is equal to 1. For 001 combination, D1 will be selected. Here D1 is set to high state, which means that the value of D1 is equal to 1, and that will be the output for Z out. So I will take up the another input combination, that is 100. So for 100, D4 should be selected. For 100, D4 should be selected. Now I will select the control pins as 100. So move this marker to 100. Yeah. So here we have SEL2, SEL of 2 is equal to 1, SEL of 1 is equal to 0, SEL of 0 is equal to 0. In that, what input, what's the output in that case? D4 is the output. You can see here the value of D4 is equal to 0, and it reflects the output, that is Z out is equal to 0. I will take up the another input combination, that is when SEL2 of SEL of 2 is equal to 1, SEL of 1 is equal to 1, and SEL of 0 is equal to 1. What's the output we should get? D7. So here I will select the input, the select inputs as SEL of 2 is equal to 1, SEL of 1 is equal to 1, and SEL of 0 is equal to 1. So here you can see SCL of 2 is equal to 1, SCL of 1 is equal to 1, SCL of 0 is equal to 1. In that case, D7 should be selected. Here, the value of D7 is equal to 1, and that's the output.